So conditionals, also known as implications. Notation for that is some statement A, arrow, some statement B, A implies B. So that arrow is an implication. Sometimes you'll see a double arrow. That. So math notation is pretty standard around the world. Logic is almost standard. There's similar symbols. So again, if you see a single arrow, that implies. A double arrow, that generally implies. So A might be the statement, I work out. And B could be the statement, I have dessert. What your favorite dessert is. Sometimes for me it's chocolate, sometimes it's a good beer. And then putting those two together in an implication could be something like, I work out implies I have dessert. Let's see, I always confuse dessert with desert. I'm 95% certain dessert has two S's. Anyone correct me if I'm wrong there. The more common way we speak that, like I don't use implies when I'm hanging out with my mom or my friends. I would say something like, if I work out, oops, extra if there. Then I have dessert.
Got an extra then.
Oh, good. Now I can fit dessert. Good job. Thanks for pointing that out. Sometimes I'm thinking ahead while I'm writing. Ham does bizarre things. Okay, then I have dessert. Perfect. And the way to think about an implication is a promise. And the promise can be broken, right? If the promise is broken, the implication is false, and that's the only time. So if, and this was a big lesson for me when I was first learning logic back in college. So if promise is broken, then it's false. So I'm using an implication to describe an implication. Otherwise, it ain't false. And if something's not false, what's it got to be? It's got to be true. So I'm going to make a truth table for how this implication, this promise could possibly work out. So the things, oops, I don't want to write in red anymore, let's write in green. The things I need to consider here is what's going on with A, what's going on with statement B, and based on what's going on with either one of those, I can tell you whether the promise was broken or not. So that would be A implies B. Okay, so what we're making here is called a truth table. So let's suppose statement A is true and statement B is true. So I worked out, then I had dessert. They're both true. The implication is true. Now, it could be that A is false and B is true. There's lots of ways to organize truth tables. I'll go over a couple more ways in a minute. So let's see. I didn't work out, then I have dessert. I didn't break the promise. I just didn't work out. That's okay. Could be A is true and B is false. Okay. I did work out, but I did not get dessert. Promise is now broken, right? Because I promised if I work out, then I have dessert. I promised that. I just broke my promise. Okay, myself is not happy with myself. Broken promise. So this one is false. I'm missing my R there. Promise. Last possibility is room there that A is false and B is false. I didn't work out. There's no promise to break if I didn't work out. I could have dessert or not. This time I didn't have dessert. Oh well, that's okay. The implication is not, the promise is not broken. So the implication is not false. So by default, it's true. Because in Boolean logic, things are either true or false. So the only time an implication ends up being false is if the promise is broken. And the only time the promise is broken is when the premise, the starting part, is true, but you don't follow through with the rest of it. You broke your promise. Okay. Now here, I organized my truth table as true, false, true, false. Sometimes you'll see them as true, 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 true for the first one, but notice that's how the second one ended up being organized. But the bottom line is A is either true or false. So I have two options for how to configure A. And B is either true or false, because it's Boolean logic. So I have two options for configuring B. 2 times 4 means my table should have 4 total rows. If I combined 3 different statements, each statement is either true or false. That means I would have 2 times 2 times 2, or 8 possible ways to configure the results of combining 3 things together. So every time basically you add a new statement into your logical structure, you double the possible ways it can turn out in the end, right? So truth tables grow fast. And here we won't work with anything more than 3 statements at once, which means our truth tables could be up to 8 rows tall. And we'll see some of that soon. But I think the biggest one to wrap one's mind around, in my opinion, is conditionals. That the only time these conditionals are false is if the promise is broken. And the promise is going to be broken only, one pen, where are you? Only when the premise is true, but the conclusion is false there. So this one right here is the only time an implication ends up being false. Every other time it's true, it's not false. So that's definitely something you want to make good note of for other problems.